Hi, today we'll speak about how to use ORTools effectively for linear optimization in general. Now, why I say effectively? Because you really don't know what kind of approach you should be using for linear optimization unless you have some benchmark data or some results of experiment that you previously have conducted, so to say. If you read case studies, a lot of the time actually the data that have been there may not be the same as yours data. So it's very important for you to know how to simulate such experiments so that you can then use the output, the results that you get from that into your code, into your product if you're developing a product. And most likely if you're watching this video, you're actually struggling to make ORTools faster. First of all, ORTools is installed by pip install. It's a library from Google. And also from Google, there's a CPSAT model that can be implemented using PyWrap, which is imported from the linear solver in ORTools. However, although this is easily imported, you can also try to import CP model directly from ORTools, not using PyWrap. What might find as an issue is that sometimes you get this error. If you pip install update it, maybe you fix it, but if you're using an environment like Databricks, like I personally use in my job, then you might find this error sometimes appearing. It really depends how you start the cluster. I don't know really what provokes it. You'll find a solution on the internet, yes, for sure, but this error does not appear every time. That being said, if you want to use a CP model, I would recommend using it through PyWrap. So what are we going to optimize today? I have chosen some very simple task. It's about, let's say, 3x plus 4y, and this has to be maximized. What are the constraints? So the constraints are x plus 2y less than or equal to 14. Very simple. Then we have 3x minus y, which should be bigger or equal to 0. Next we have x minus y to be less than or equal to 2. All right. What should we first do? We should import it as we did it, and then we should create our solver object. So I'm going with solver to equal PyWrap lp.solver. If you click on tabs, it will be easier. It's not the typical Python case like a create case. Here is a camel case. Usually if it was in Python, it should be snake case. Anyway, then here we should, with shift tab, as you may know, in notebook style editors, you'll be able to see the doc strings and some additional information. So you can see here all the type of functions that we do have. Now I'm going to go with something very simple for this. I'm going with glob. So this is the primary, like most recommended starter, let's say, to use. In really a lot of guys you see this. It's okay. So first we're going to build our general solution, then we're going to try to find a better way of doing it. Then we need to create our num variable. So I'm gonna go with x is equal to num var, which is bigger than 0. So 0 till solver. Now we need to get infinity. So to get infinity, we need to get it from infinity. Maybe it's, yeah, with a capital, it's okay. Then we need to provide the name of the variable. So this is how the variable will be named, and this is basically the object that we'll be using for our optimization. Then we need to create the y. Basically it's the same thing. I'm gonna copy it and the only thing that I'm going to change is just the y. Okay. If we now try to see how many variables does our solver has, we're going to look at num variables. Oh, this is a method, yes. So we have two. That's how you can check how many variables you have. Good. Next up, we need to add the constraints. And like I said, add. So it's solver dot add like this. And then literally we're going to write what we wrote above. The only thing is that here I'm gonna place a star. So I'm just gonna copy it. Actually, it will be easier, I think. And here I'm gonna go with 2 times x plus 2 times y. Less or equal than 14. Yeah. Good. I'm going to copy paste this, and I'm actually going to do the same here. That's why this package is so easy to use, because it's relatively straightforward. At this stage, of course, if you're performing complex tasks, you need to think how to do it a bit more. Next up, we have x minus y. That's what we do. Now, what I would recommend here is to put these variables as floats. Again, I'm not expecting a huge increase in performance, but it's better to be in floats. And coefficients usually to be in integers if possible. Right. Now, we run this. Okay. And then we can do the same with the number of constraints as we did with the number of variables. So, and we have two. While we have two, we should have 3 constraints. All right. Next, we need to set the objective function, which is basically solver. Then we need to provide the target, which is maximize. And we are going to go with our function, which is 3 times x plus 2 times plus 4 times y. And this is basically what we're going to do. And now we're going for the solver.maximize, solver.solve. And this will be our status. Good. Now we can do a check if our status is equal to optimal. So pywrap p dot solver dot optimal. It should be all capital. Yep. This is like a status. I can do an if, but I can just go with this. It's true. That's super cool. And yes, we can basically take the objective value, the solution value, and so on. How to do this? It's super simple. To get the objective value, you just go with solver.objective.value. How you need to call objective? I'm sorry. Okay, so objective.value. I doesn't have a. Yep, it's 33, and the same you can do for x and y. Actually, in x and y, you just need to type solution value. this, and here at y, same thing. All right. So in the next video, we're going to see how to optimize this or how to build a benchmark about all these methods, how to actually take the best method.